As another example, let's imagine that we have an object that, again, starts at the origin. So here it is. It's an object of mass m, say 2 kilograms, and it's, let's say, moving with some velocity in the x direction. So it has a v naught x of, let's say, 1 meter per second. So it's moving along this way in the x direction. But it's acted on by two forces. So, well, I don't want to draw the forces on a diagram where I have a velocity. So let me put the object over here and draw forces. So let's say there's a force at 45 degrees. So there's an F1, and that could be, let's say, 1 Newton this way and 1 Newton upwards. So 1 I hat plus 1 J hat newtons, which of course is just I hat plus J hat. And say another force, which is, what do we want to do? Let's say it's just along that direction, call it F2, and make it, I don't know, it's 2 newtons. So it's 2 I hat newtons. Let's find the acceleration, velocity, and position vectors as a function of time. So the acceleration vector, we know, comes from F equals ma. And so we have to look at the net force divided by the mass. And that force is the sum of the forces. So we have I hat plus J hat plus 2 I hat newtons over the mass we said was 2 kilograms. So this gives us, right, the dimensions don't speak to each other. So we have 2 and 1. We have 3 I hat plus 1 J hat divided by 2 meters per second squared. So that's the acceleration vector. It's a constant. What's the velocity vector in this two-dimensional space? Right, so we're sort of moving on a table. This is an object that's launched initially this way, and it's just moving on a table, so there's no gravity. So the velocity is, we have to integrate, right? So we have the x component. We have the v naught plus a times t, and the a is 3 halves actually. So we have 3 halves t plus the v naught x, which in this case is 1. So we have 1 there, 1 plus 3 halves t. We're integrating this, I hat plus, I have 1/2 for the y component. So I have 1/2 times t plus v naught y, but there's no v naught y. So I simply have 1/2 t j hat. I don't really need the parentheses, but I'll put it there just to indicate the component a little more clearly. So that's the position as a function of time, which is clearly, that's the velocity as a function of time, which is clearly changing, and the position in this two-dimensional space is going to be, I'm going to integrate that, I'm going to get t squared over 2, so I have 3/4 t squared, plus v naught x t, v naught x is 1, so I get a t there, plus the original position, or x component of the position, which is x naught, that's the origin, so that's 0. So I have I hat plus, here I have t squared over 2, just like I do there, and so I have t squared over 4 plus v naught yt, which is 0 because v naught y is 0, and then plus y naught is 0, so that's all I have, and I'll leave it like that. So there are my acceleration, velocity, and position vectors.